start to begin with the presentation. So there are multiple introductions for that question. So first one is the material, I guess. As you know, the stone, glass, plastic, there are a lot of important material that convert our design industry throughout the human history, right? So this is the picture. People living 19th century, they thought about what the future looks like. Yeah. So at that time, the railroad industry hit the urban design. I mean, all people think about, oh, railroad gonna change our life, right? As you can see here, in the 21st century, they thought that the railroad can carry the building just like this on the left, the picture on the right, they also think about like, what if we, combine the ship with the railroad? I mean, these are their imagination for the future, right? But I guess it never happened, right? Because we live in 2021, right? The reason, I guess, is that they need to little mismatch about what their important material, what their important paradigm shift. So previously, up to 19th century, all important revolutions happen in the physical world. But I guess the most important, a little bit most different, the sort of revolution is happen in the physical world, not just physical world, but more about like in the digital world. We call it data. I mean, data is most important resources for the 21st century. So in order to use the data, we need to think about what the software. Yeah. When I say software, if you guys think about, maybe SketchUp or some application on your smartphone, yeah, you can consider them as a software. But if you understand software on that level, we actually overlook the power of the software. My understanding of software is more about like package knowledge, tech knowledge as a sort of an executable form in the mobile way. Yeah, so it's easy to distribute to everyone. But as you can see, the software has, as I said, like a lot of knowledge and technology that have been built throughout the human history. Like think about like the Pythagorean theorem. Yeah, without this kind of things, we couldn't do any other geometric problem, right? So I really like the term like on the shoulder of the giants. Yeah, because even if there's a important revolution, they actually built the revolution on top of the existing knowledge. Yeah, but the power of the software is actually we can make all the knowledge as an executable form in a really quick time. So as I said, we have knowledge and technology, and then previously we actually document them as in the book or document form of the data. Yeah, but the software is, as I said, we can package them in an executable form. But not many people talk about how fast a computer can compute. So in the smartphone, for 1 second, it compute like a 1.1 trillion computation. For the very well-trained the pro gamer, they actually do like, I don't know, around 300 action per minute. Yeah, so we can call it IPN. Yeah, but for the computer, it can do like 666 trillion computation per minute, which is absolutely fantastic medium for design or for processing data. Yeah, and just think about it. What if we have no electricity or no software? I'm probably, I said like 99.999 company gonna stop throughout the world, right? What I'm trying to say is that all the design companies rely on the software a lot these days. So we can jump quickly a little bit. So yeah, now we know the importance of the software, right? So software has a lot of knowledge and technology that we built throughout the history, and also we can execute really quick in a time. So the software is basically genetic tool for people. Yeah. So what does it mean by the generic? Generic means like it is more the software is there, so we can use this software for multi-purpose, right? But for the designers, sometimes you guys are landscape architect designer. Even landscape architect designers, they need customize the tool for their particular projects or particular design issue, right? So we can actually customize the software as a more, how can I say, more like let's say customized software. So in order to customize software, we need to learn the code. I think this is one of the answer why we designer need the code, because the software itself is too generic to apply your particular sort of design issue or design projects. Okay, and this is the other approach. Yeah, I guess you guys heard that keyword a lot these days, right? AI, machine learning, drone, autonomous vehicle, parallel computing, edge computing, and so on. There's a lot of keyword, right? So what does it mean by that? This keyword is indicating like a fourth industrial revolution, right? So you guys are on the right stage. So I guess what my understanding of the fourth industrial revolution is more about like how we collect data, yeah, first, and how we process the data, yeah, how we extract the insight from the data, right? How can we apply, utilize, harness the insight which is from the data to our living, right? So what I'm saying is the important resources of the fourth industry revolution is about data. This is what I'm trying to say. So we can think about like, as I said, we can deploy the knowledge or technology and as I said, the computer is really faster. Yeah, we can actually just like focus the individual the keyword into one things. What I'm saying is the most important thing is the data. Data is the sort of a new material for the designers. Yeah. So the data is as I said, resources just like a concrete, just like an iron, The individual sort of material need their tool to process, right? So how we cook the data, this is my question, yeah? So is there any tool, physical tool to cook the data? Yeah, maybe, yeah. But from my experience, I think only tool is to cook the data is the code. You need to make a code. You need to make a statement to ask a computer to do something. Yeah. So that's this is my answer to why designer need to learn the code. Right. So first one is creativity. Second one is automation and optimization and design methodology. These are sort of the writing that I wrote for why designer need to learn the code. I can quickly say like, you can actually think about when you create the code, you can think about, I can develop your own employee, right? This is my sort of philosophy. Whenever I need to create my code, I'm not trying to resolve the problem directly. I'm just trying to describing somebody who resolve the problem on behalf of me. This is, I think, the most important mentality to make your code. And also, obviously, computer is really fast tool, so the computer become like a important sort of helper for how can I say, like the repeated tasks, yeah. And also we can do optimization with computer, because computer can, using the brute force algorithm, we can compute every single possibility, and then we can think about as a sort of statistical approach to pick one of the sort of the candidate for your solution, for example. So there are many ways to take a look at why need the designer need to code. We can jump a little bit. Yeah, I mean, this is the sort of the misunderstood for designers. This is my sort of experience. Most of the designers who has no idea about the computation, they actually stay at least three of them here. The first one is people think about like computation design gonna replace what we already experienced, what we already used to, right? But my answer is no. The computation design is more like augment your ability to design. It's not like a replaceable. Yeah, just like think about it. Even if the touch screen or mobile application is invade our life, but still we need a pen and a sketchbook, right? This is, I think, one of the examples. Also, the computation design is another magic box. Yeah, the computation design is more about like encapsulating your thought process. Yeah, this is, I think, a good statement. So some designer think about computation design. If you give me input, you're gonna give us like output. Yeah, it makes sense. But you need to describe. You need to specify the individual statement to do sort of an action script. Yeah. So it's not about the magic box. You can pick think about like entire design process, right? So we can pick like a very small sort of a moment. We clearly know what is the design issue, what is the result we wanted to make out of this issue. So we can create a very like an explicit design process, and then we can just writing as a computer language. Yeah, we can call it coding. Yeah. So there are other statements. So you guys can actually I made the other lecture in Korean. So you guys can visit my YouTube. There's the Korean version of this sort of the lecture for 3 hours, I guess. So now we are facing the chapter 3. So then, okay, I understand, NJ. So what we can do, what we can expect, the design with data. So these are example how we use the data for the design process. So let me quickly check the time. Okay. So we have a data at different scale, different sort of level, yeah, for the design. From the geometry level, like product, geometry scale, to the all the way up, like GIS, geographical or urban or landscape scale, right? And the most important thing is that like a methodology, because we are dealing with the data, right? So there are conventionally well-defined way to dealing with the data. And particularly, we are architectural landscape designer, right? So we are basically dealing with the data on the spatial. Yeah. So we need to understand how we capture the space as a data. Yeah. There are multiple ways to do this, but this is the one of the way to graph. Graph is basically one of the conventional data structure for computer science, but we can actually freeze and then capture the spatial data into the graph. The graph can deal with sort of like a discrete data, yeah, like a one-to-one. It has a node and edge. Node is mainly resolve sort of the geographical location position, let's say. And then also it has a sort of metadata related to that position, right? And then edge basically resolve the connectivity between points. Yeah, this is the important description for the graph. And then pixel and voxel, they're also dealing with the discrete data. Yeah, not only just continuous data, but as you can see, the density of the pixel and voxel, we can actually deal with the continuous data, which is more about like a real world data, right? So there are some of the methodology to dealing with the data, as I said. I think we are, the reason we code is, as I said, in order to cook the data. So data is really important. Again, we not only just dealing with the data, but also we dealing with the data which has the position, geographical position data. So this is a little different than the computer science or the data science people. Yeah, and also we need to specify the system, how we cook the data. Yeah, so we basically create a pipeline. Yeah, so that's why call the software engineer. We can sometimes call them like software architect. Yeah, they actually build the architecture. Yeah, they are call themselves we are software architects because they build some structure pipeline, like some let's say the partition for the data as they process. Yeah. So these are some strategy. This is, I think, more friendly term for the designers, like optimization, automation, agent-based or multi-agent-based design system, rule-based system, or generative design system, interactive design system, data-driven, there's a lot of terms, to describe. I mean, this is a little different than emphasize. I mean, if I emphasize sort of the agent-based thing, so basically individual, the policy, they have their own sort of way to cook the data, and then they play in the space, and then they behave based on the designate the description. Yeah, so we call this agent-based. I mean, most of them is very similar computation, but we emphasize. I'm just express what I wanted to do, right? So these are sort of understanding the keyword. I think what I'm saying is the keyword is nothing special, to be honest. Yeah, again, data. We have a data, right? And then we have a methodology to cook the data, right? So we can basically encapsulate. We can, write the sort of the instruction for the computer language. I think we can call it the system. Yeah. Okay, great. This is the one of my research work at the Media Lab. Okay. Okay. Something wrong. In this project, I deal with this one. Yeah. The presentation board a bit heavy. Yeah, this one. Okay. Yeah, I think I have like around 10 minutes. Yeah, I can jump quickly. Yeah. Yeah, this is the example how we use the graph data structure for the processing, for processing urban data. So what I did is basically to not only just create the data structure to process the data, and then I used the Google place data so that you can actually search all the third place. The third place is more about like place between home and work. Coffee shop becomes third place, ATM place, or pub, or what else we have, like library, all place become third place. So I extract the third place data and then process them, and then try to correlate, try to extract the correlationship between third place. So this is all the video. If you guys are interested in, visit this sort of the video, see all the process that I did. And also I submit this paper to the Digital Futures that happened last year. So also you can download the paper. So the one thing I can emphasize is that we have urban has a full of data. So we can convert the not only physical entity, but also like or emotional or human behavior as into the numerical the data, then we can process it. So this is the example. Yeah. This is the other example using the urban data. Yeah, we can just present just like that. Yeah. This is the machine learning. I did some machine learning research class. So it's nothing special compared to other sort of prediction for the land use or land price. But what I wanted to emphasize is that in the design process, at that time it was a little innovative, but these days not, but I executed like this project in 2016. Anyhow, so I parse all the Google Street View. So this is, I pixelated the Boston area here. So, and then I can download all the Google Street View around the 360. And then I semantic segment basically converted the image into numeric data. So as you can see here, so we can see how much percent we can see for the sky or for building or for tree. So we can basically, I'm trying to, what I did, I'm trying to do, capture the human perception into numeric numbers so that we can process them as data, right? So these are one of the way, doing this. And then since the data is all number, so we can also borrow a lot of terms from the statistical approach. So there's a lot of insight to process the data. So again, the most important thing is the domain knowledge. Even if there's an insight, I have no idea about the landscape, but but then it's really dangerous to use the data directly. So I think the most important thing is that at the end of the day, you guys need to fully take advantage of your domain knowledge to interpret the result from the data. I think this is also important things. You can jump other things. Yeah, this is the one of the sort of exhibition that I did with the Dong-Se Kim, who is the professor in the NIIT. So what we did is a similar approach. At that time, the Solo was open to the public. So we actually collect the data for 1 month by Instagram and other Twitter, yeah, I think text-based Twitter, yeah, so that we can try to compare between Highline in New York and the Solo in Seoul, yeah. So what is the relation or correlation? Also, there's some video, so you can see the result, yeah, because we have limited time. I'm gonna jump it. And also, this is the other sort of the plugin that I built with the Jung Hyun-woo, who's the doctor's person. So this is a very deterministic computation process. Previously, we talked about the image data to the numeric data and other urban data. But I think the data has a lot of bias and noise. Yeah, but in this case, we can. I mean, there's two ways to compute. One is a very deterministic computation. You know, as name stands for, deterministic means every time you can calculate, the result is going to be exactly the same, right? And then the other way around is the stochastic the computation. It's like based on probability, yeah. So machine learning is stochastic computation. So here, this is a very deterministic process. It's like just like shortest path, but there is a lot of the important and well-known, as I said, the people develop how we sort of understand the urban context based on the distance. Yeah, so there's actually plugin you can download from the Food for Rhino if you use the Rhino. There's like a degree and betweenness and closeness, and this is a lens of how we analyzing the particular position throughout the urban context. So also, I think you guys also use for the landscape, I guess. So these are pervasive sort of the methodology to analyzing sort of the network, urban network. This is my thesis project. What I did is construct and reconstruct 3D geometry. So not just construct and reconstruct, but I'm thinking about what is the creativity by machine. Yeah. So this is the video, a short video. I'm gonna play the video quickly. Yeah, these are process, pre-train, train, and post-train. I think the train is pretty simple. Yeah, I mean, in order to create the pre-train, I'm just trying to voxelize the 3D geometry into 2-dimensional or 3-dimensional pixel, yeah, so that we can train it. This is one of the ways. So we can slice it. Otherwise, we can rotate all the facade of the furniture, for example, and then we can capture as a 2D image. So we can actually just think about like 2D image is a slice of the voxel, yeah. So this is the other way of the how we rasterize of the geometry in order to train the network. And then I train the network. And this is how we reconstruct from the geometry data out of the result from the machine learning here. So this is the result. And actually you can build the geometry just like that, but we need to add a post-process to smooth the geometry. Otherwise, the geometry is too rough. And this is an interesting result. As you can see, I just draw the sort of the chair like that. And then this is the outcome. You know, the machine that realized this, the depth of the chair. This is the arm part. Yeah, the white is more close to the camera, and then the dark side is more further from the camera. So this is the interesting result. And then based on this sort of the depth, the information, we can rebuild it just like that. And also not only that, there's a ranking system. So if you draw something, and then we can extract the result based on the length, and then I mix them, yeah, as a blend. just like this is some result. This is my exhibition here. This is obviously fake. Yeah, and also we can do some optimization things, but I'm gonna skip it. You can also apply the structure optimization for the agent-based things. So this is the column optimization I did for the research. We can quickly see the video. There are multiple rules, yeah. So we specify the entrance and then destination. Yeah, I'm just gonna skip it. And then this crazy line is a trajectory of the people. Yeah, the people try to starting from the starting point and then designate go to the destination. In the meantime, they try to push the column because I don't want block and other things on my path. Yeah, and then also the columns try to move to the right position to support the ceiling. Yeah, there are different sort of the let's say purpose, and then they fight each other. Yeah, it makes sense, right? But sometimes their fight is gonna be sort of the infinite loop, so that there's no sort of the tangible result, meaningful result. So we can do some meaningful iteration. As I said, this is a sarcastic process. So we need to do as much we can do in different situations, and then we can collect all the result, and then we can track what kind of action sequences can result this kind of the result. So then we basically froze all the process. Yeah. So these are sort of the higher level description of this project. Yeah. And then again, I think the landscape designers, architecture designers, whatever designer, they're dealing with the geometry. So I think the understanding of the geometry is really important. I mean, there is a geometry itself is a full of data, to be honest. Yeah. I think you guys use the knobs or B-spline sort of the shapes. It has a point, like a vertices that specify particular area. And then in order to interpret the curvature, we have some mathematical equation behind the scene. So think about it. We have a two position, right? And then we have some interpret the sort of the algorithm to generate the data. If you call some the data. So these are very interesting issue to me, because if you take a look at out there, there's a lot of data collected by local government or whatever institution, and then the data is just data, and then you need to process the data as a sort of the information, yeah. But the information is a sort of how can I say? This is not raw data. You basically process out of the raw data, right? So you can at the same time you need a system to process the raw data, and then it has a multiple sort of opportunity and parameter to cook the raw data into little different information. Yeah. So what I'm saying is the data itself is a process. Yeah. So in this case, the geometry has their own sort of particular like a designated data vertices, for example, and then the interpretation can be changed. Yeah. Based on the equation that you use to interpolate the two points. Yeah? I mean, maybe I think I'm diving too deep. Okay, let's move to other funny thing. Also, we can optimize like the position. Yeah, so maybe you can create some graph just like that, and then the individual tree need to make some distance for some reason. For example, I have no idea about the landscape design, but I can just imagine. I can try to make some scenario to create the data, yeah, for example. So in this case, we can specify some rule, and then they just trying to push each other up to and as long as they make some distance between the individual rectangle, they stay there. Otherwise, they push each other. Yeah. I mean, this is a sort of the agent-based the optimization thing. Yeah, I'm gonna jump it. Yeah, I think this is the plugin that I built for the landscape students. And we can see this video bit. There are two things. One is the render objects, just like tree, and sun and other things that create our environment. And then the land. Land is basically the process to data, process data. So for example, I build this kind of the sun path here. So we can specify like time, a day, and location, and then it gives us the exact sun vector. Yeah. And what I'm trying to say is that we can, okay, so this is my land, this is my build. I'm trying to compute which one is the more space to be exposed to the sun, for example, because some tree need to expose particular hours during the year, for example. Yeah. In this case, we can voxelize the space just like that. Just like that. As you can see, the size of the voxel is the amount of the hours to be exposed to the sun. This is the yearly average shadow in voxel. Yeah, as you can see here, so that you have a better idea, better chance to put the tree, right? Yeah, I have no idea, but I'm just trying to make some use case for the data. And also, at the times, when I built this tool, I asked my landscape friends and professor at HSD, my understanding of, I mean, I'm trying to discretize and then process to extract the data. According to the landscape people, they said the most important things to measure the soil quality is that like the dampness and the slopeness, like soil hardness. Yeah, these kind of things, parameter to specify the land quality, for example. So I can create something. So this blue said like this is water dampness. Yeah. This is the pH, the level, yeah, I guess. Then this is slopeness and then water dampness. So what I'm trying to say is that we can characterize some the data, and then we can process the data as a land, and then this data actually can talk with the land object. Yeah, in this case, the land object is going to be tree or bush or things like that. And then they basically talk to each other, and then, oh, their soil quality is like that, so you need to grow that much. Yeah. So basically, land and the tree object, they basically talk to each other. I'm trying to make some simulation. Yeah, it's nothing special. So these are how we use the computation design for the landscape design or land use tree. Yeah. Forgive the lack of knowledge of the landscape. Again, we have data for the image, right? The remote sensing is one of the important data process for the GIS, not only GIS for the urban or the landscape designer. So this is a tool that I developed. You can download from the Rhino. So I'm trying to make some color difference and then extract it, like for example, like I want to extract like the area for the river, or area for the tree or park, things like that. This is all about the image process. I'm gonna jump it. Yeah, I think that the mapping is really important. Yeah, for sure. Because I'm working at Esri, so we have a lot of clients. It's not only just the conventional GIS people, but also we work with the local government for the landscape. Yeah. So this is the tool I developed at Esri, which has a little computational things. So I just wanted to skip it. Also, we have a limited time. We have as I said, we have a data for material, yeah, and data for the fabrication here. Yeah, these are all the opportunity and interaction for the data. Yeah, you can jump it, keep jump, and also we can create some sort of game. I think this game is built on top of the numerical land utility. So as you can see here, so we have you can see the movie a little bit, because I'm trying to create the small ecosystem. So we have a small ecosystem here, right? We have a sun, yeah. Obviously, sun helps the tree grow, and then I want to jump it a bit. you can click it, the cloud produces the raindrop. Yeah. And the raindrop, the tree can consume the raindrop, and then tree gonna keep growing, right? And also when they grow enough, they try to create their own family around their tree. Yeah, which is the rule. And also you can extract the tree from the ground and then become timber, right? And then you can put the timber to the factory. Here's point. Yeah, then you can get more resources, but at the same time, your carbon dioxide is like a increase. Yeah, I mean, these are sort of like the system. As I said, we define the system based on the data, and then you can intervene. Your design decision can intervene the result. Yeah, so this is the basic playground machine and the human being to build something. Yeah, I think this is the good statement for the beginner. Also, there's some demo you can see, and also you can use the fluid dynamic system. Yeah, this is I think also important for the understanding the urban context. I'm gonna jump it all the way up. We have a limited time. So these are several examples, and I have some lecture or workshop if you guys are interested in learn the code. So there's some Python or C# workshop, and also I did some computation design workshop. The other conference, I'm talking about like a Python and computation geometry, and then create the pipeline for the design processing. This kind of workshop will be online. You can download, not download, you can watch the video. All the class materials are online. And also I have the Medium page. So I'm writing multiple books like for the novice user, just like you guys, how to encourage to learn code. There's a workshop and some class and book material, then you can download it. Yeah, so there are 3 questions, yeah. As my last slide, I'm sorry for the Korean. Yeah, my first question, answer to that question is that obviously you need to learn the code even if you are not computer science people, because as I said, the data is the most important resources. I have a nephew and niece. They actually learn the code in the school, like a middle school, because they talk about like the data. This is a very interesting point to me. So again, your competitor is not your friend. Your competitor is my nephew and niece. They already learned the code in the middle school and high school. Okay, this is very fascinating or like a powerful statement, I guess. And then the code is the new tool. My answer to that question is no. Code is not a new tool. Code is just augment. Yeah, actually, you know, Rhino or SketchUp. Actually, there's a even if you call the UI button and then the something happen behind the scene is exactly that you can code. Yeah, so the coding is something new. It already have there, but there's a lot of layer to hidden the hide the complexity. So the complexity is there. You can, as long as you can customize the complexity, the freedom gonna be expanded. How to study? I mean, the learn the code. I mean, there's a lot of material. So yeah, sorry for the rush for the last minute. I think we have only 3 minutes for 1 hour. So if you guys have any question, please let me know. We can discuss it. And so my answer is yes and no. Okay. It depends on the people, I guess. I think, but this is a good question because this question possibly understand how we, prepare for the computation design scale experience, I guess. Because I mean, this is just a tool, right? Yeah. The client doesn't care whatever software you use, right? You can use the SketchUp, you can use the Rhino, you can use whatever things, whatever tool, software tool or physical tool to develop your idea, right? But, if you have a better tool or if you have a better software, then you can save your time. Then you can allocate your time on the more, design process or whatever extra things, right? So coding is just like that. This is nothing special. This is just like a, just advanced tool, but it needs a time to learn in the first place. But once you learn it, then it gives us a lot of opportunity. Just like for me, for example, I have a lot of library. So when I listen at the design issue from people or my client, then I have to think about like what I did in the previously. And then there's a multiple level of the library. On the low level library, they're all mathematical equation, just like resolving a particular problem. And then on the middle level, they actually talk with the low level, just like a middleman, like assemble or disassemble the low level. And the higher level is a design issue. So this is my thought process. So when I have the design issue, and then I try to think about like what I have been done. Yeah, what I'm saying is the coding looks like it takes time to create the process, or it has a lot of time to learn. Even the learn. So what I'm saying is that right now, I think as it is good. Just focusing on your own design, and then as your time, then you can expand your skill set. Yeah.
Okay.
In the 5 year or 10 year, we mentioned the software and the coding or computation design is gonna be important skill set for the designers. Yeah, I can see the paradigm shift right now. But right now it's okay. As I said, just keep studying your main design domain. Then as a tool, you can spend allocate little time and then increase your skill. And up to, when you say the computation design, just don't think about like, don't think like parametric crazy.
Yeah, that's what we think.
This is one of the examples. The reason why we computation designer use that kind of shape is because there's the only way, not only way, it's an easy way to shape this kind of complexity. That's why people use the code. Yeah. What I'm saying is I teach my students like, oh, don't do crazy. Just like an even simple box like Korean style apartment, you can parameterize. You can apply computation design philosophy on that thing. I think that one is the good like a starting point to understand computation design. Not think about like crazy facade or crazy thing, but more about like discretize the process. Yeah, and then you can write explicit sort of the language to the computer, the step by step. I think this is computational thinking. I think this is more important rather than crazy shapes. Yeah. One more additional things to that issue. So the slide reminded me of you can think about like little difference, like we can draw the apple, for example, right? So our brain already shape some apple shapes or color, whatever things, and then your hand is basically replicate your thought, right?
Yeah.
So I think that we can think about like this kind of way to draw or designing the apple, for example. And in a computational way, I guess I'm trying to think like you can specify the environment or like the level of the shape, for example, like highlightness. Like highlightness cannot be affect the color of the apple. And then the apple shape cannot have like some sketch or like some randomness. We basically define the environment that gonna shape the apple by number. So you can play with the number a little bit, and then how we think about the combination of the individual parameter can result in different apple. These are little different sort of the thought process between like a repetitive, conventional like a design process and then computation way. Because computation is more about like design the environment, and then the result is gonna be outcome. Yeah. The Dennis Hassabis who developed the DeepMind, they actually created the AlphaGo, right? So everyone remember the event for the AlphaGo, right? So his PhD dissertation is about the memory or creativity related to human brain. All sort of creativeness is stemmed from the past experience. Yeah. So machine learning is one of the way to let's say achieve artificial intelligence, right? The machine learning is more about like there are multiple ways to achieve AI, but machine learning is learning the past experience and then keep tuning, and then we keep giving the answer and then the question, and then we actually tune the parameter and basically learn the past, and then in the future question we give the answer based on the past. I think this is also a very similar approach. And also, I participated in the some of the AI design talks and with my friends. And then I'm keep asking, like, what do you think about like the creativeness or creativity by machine? Because I really want to understand or learn how people develop their sort of definition of how we use computation design for the creative practice. I mean, there is a lot of ways. I mean, the most important thing is the human being. They have their intention. They have their sort of let's say human can computer generate a lot of design alternative, and people can give us like a this is creativity or not. But my sort of I mean, for my the thesis project, I thought possibly error become creativity. So some error is obviously error, but some error is, we never created before, right? Because this is sort of like the error, right? So I think the possibly error or something from the past become creative shape or creative idea on that context.
Yeah.
I have one thing to say, because the Dongil reminded me of one thing, which is previously somebody asked me how apply the computation design for our design projects, because the design, there's no actually correct answer, right? So as Yumi mentioned, we have only one client, and then the decision maker is myself. So it's really hard to make some, as Dongil said, like not easy to make a consensus, right, between people who has a different background, different ideas, things like that. So this question has bothered me for a long time, to be honest, because I'm computation designers, and actually my background is architectural design area. So I have one possibly closest answer to resolve that question. Is the answer is engineering things. Yeah. So to think about like Dong also mentioned optimization and the data-driven something, right? So optimization means that we actually have no idea what is the optimal situation, but we know there should be optimal situation. So we need to find the optimal situation, right? This is sort of a journey. We have no idea what the destination, but we know there's a particular very optimal situation and status. So in that context, the most important thing is that, as I said, like engineering. Engineering means nothing special, more about like we have a measure system, we have a criteria. So we have some particular lens to analyze the design alternative. We're gonna have a number, right? So there's two ways of optimize the engineering things. Some is the minimize the value, so the other one is maximize the value, right? So for example, so we are landscape people, so basically let's say the shadowness or some path is important, right? So we actually have this kind of environment, like we have a building and trees, some existing context, right? And then we have a sun, right? And then we can actually compute the some path so that we are able to get I mean, my understanding of data is more about like how capture world as a numerical information. That's it. Yeah. So we have a capture the actual the environment, right? And then we have a measure system. Yeah. So in between, this area is a more optimal area for that tree, for example. I mean, that tree, we need to make sure for that particular slope to make the water stream, for example. This is a measure system. As long as we have a measure system, we can convert it as a number. I think number is really important. So to answer the question, to optimize and then make a more consensus, I think in this case, the question is not focusing on the design process for now, but focusing on making the criteria, making the measure system first. As long as everyone agree the measure system, then the process is become easy way, because we know what is the result, right? Just think about like the structure analysis. If the structure is not met, the building gonna be collapsed. in this case, we can actually add the other parameters. So for example, like you mentioned like a very good example, but we can add other parameter like a time, for example, like a seasonal. So we just narrow down because within the parameter, it's really hard to find the sort of the optimal way. Then we can add other parameter, make a more procedural or process. So in this case, the most important thing is that we build a hypothesis. Yeah, I think that I really like the hypothesis because hypothesis as its name stands for, we have no idea, but this is my guess or this is my thought. And then we can, based on hypothesis, we can extract a meaningful parameter and then inject meaningful parameter to the existing parameter that you mentioned, like the moisture and then wind and things like that. So that at least I'm client, for example, for you guys are all the designers. So this is my site, and then my hypothesis, based on your purpose, we have this kind of scenario, this kind of the guideline for engineering, right? So that you can extract the parameter. It's basically describing the process. Yeah, I think as long as the process is made, the result is gonna be just like a byproduct. Yeah. I mean, this is one of the way to, I'm a computational designer specialist. I'm just trying to emphasize one idea. But what I'm saying is this idea is not always right, but I'm just, because of brainstorming purpose,